So we're continuing our section 2.1 notes on laws of exponents. In your packet, we're on page 7. We talked about 4 laws last time. When we multiply variables, we add the powers. Power to a power, we multiply those. We can distribute exponents to a multiplication problem. When we divide, we subtract the powers. 2 more laws we're going to deal with. First one, go to your calculator and tell me what 2 raised to the 0 power is. 2 to the 0 should give you 1. Try something else raised to the 0. Are you still getting 1? Law number 5 says that x raised to the 0, anything raised to the 0, is going to be 1. Actually, not quite. If x itself isn't 0, we can't do the problem 0 raised to the 0. Maybe we'll talk about that in a moment. But right now our rule is anything raised to the 0 power is 1. I think we should probably talk about why this works. Well, if I have x squared over x squared, by laws of exponents, when we divide, we subtract, so wouldn't this be x to the 2 minus 2, or x to the 0? But in the same breath, isn't x squared over x squared like saying x times x over x times x, and everything cancels in a fraction, just giving us 1? If I think about it the canceling way, I get 1. If I think about it the subtracting way, I get x to the 0. You're going to have the same amount of stuff on the top, and on the bottom, things are going to cancel, and you're going to get 1. X to the 0 is just going to give you 1. Let me show you 2 easy examples. Letter A, z raised to the 0. What is z raised to the 0? I hope you said 1. A little more involved. Letter B, x squared y to the 4th over z to the 6th. That whole thing raised to the 0. What's that? I guess there are 2 ways you could do it. You could distribute your exponents and get x to the 0, y to the 0 over z to the 0. Or just realize this thing to the 0, it's just going to give you 1. That's it over there. One thing that I mentioned to you, I told you we can't do 0 raised to the 0. Go do that on your calculator. What does your calculator say 0 raised to the 0 is? Hopefully it gave you an error or something like that. Actually, we're going to call this undefined. You don't have to write this down. Just watch. Okay, how are we going to do this? If we have 4 raised to the 0, that's 1, right? 3 raised to the 0 is 1. 2 raised to the 0 is 1. 1 raised to the 0 is 1. So, according to this pattern, 0 raised to the 0 should equal what? Should be 1. Because I think this pattern makes a whole lot of sense, because anything raised to the 0 gives us 1. Well, what if we do this? What's 0 raised to the 4th? 0 times 0 times 0 times 0 is 0. 0 to the 3rd is what? 0 times 0 times 0, that's also 0. 0 squared, 0. 0 to the 1st, 0. So by this pattern, 0 raised to the 0 should be what number? I've got 2 very valid patterns here. One of them tells me 0 to the 0 should be 1. The other tells me 0 to the 0 should be 0. That's not how math works. We need to get the same answer no matter what pattern we're using. So because we're getting 2 different answers, we have to say undefined. 0 raised to the 0 is undefined. If that confused you, don't worry too much about that. All you need to know is any number raised to the 0 gives you 1. Back in our notes. Law number 6, negative exponents. Go to your calculator. Tell me what 2 to the negative 1 is. I think it probably gave you 0.5. But if we write that as a fraction, we can say it's 1 over 2. See if you can do 4 to the negative 2 on the calculator and get a fraction answer. What is that as a fraction? If you were able to on the calculator, we should be able to get 1 over 16. Well, let's see, 2 to the first is 2. 4 to the second is 16. It's like I'm just doing the regular power and sticking the thing in the denominator. X to the negative 3 is just like saying x to the third in the denominator of a fraction, 1 over x to the third. Our sixth law of exponents says that if I have x raised to the negative a, if I have a negative exponent, this will be 1 over x to the a. Get that copy done. There's a second part to this law. On your calculator, can you type in 1 over 2 to the negative 1? And you're going to have to be careful with parentheses. You're going to say 1 divided by 2 in parentheses to the negative 1. What is 1 over 2 to the negative 1? I think your calculator should be telling you 2. How about B, 1 over 4 to the negative 2? I think your calculator should be telling you 16. Basically, I'm pretending like it's a positive exponent and moving it from the denominator to the top. So 1 over x to the negative 3 is just regular x to the third. Therefore, if I have a negative exponent in the denominator, 1 over x to the negative a, I'm going to get just x to the a. These are the ideas behind law number 6. I'm going to fill in the box, but then it's also going to be easier to write it in words, I think. Law number 6 says x to the negative a equals 1 over x to the a. And 1 over x to the negative a is going to equal x to the a. Might be easier to think about it this way. If you have a negative exponent in the numerator, we're going to make it positive, and we're going to move it to the denominator. If you have a negative exponent in the numerator, we are going to make it positive, and move it to the denominator. Similarly, and then I'll make the video pause after I write this, if you have a negative exponent in the denominator, make it positive and move it to the numerator. If you have a negative exponent in the denominator, make it positive and move it to the numerator. Please copy this down, and then I'll show you a bunch of examples. Okay, so on the next page, x to the negative 6. Well, according to the rules I just gave you, how can I rewrite this? I think this is just going to be 1 over x to the 6th. What about b? What can we do in b? A negative exponent in the denominator, I can move that up and make it a to the 7th. A to the 7th. In letter C, they both have negative exponents, so really I'm just going to switch where in the fraction they're showing up. X to the negative 7th becomes x to the 7th in the denominator. Y to the negative 8th becomes y to the 8th in the numerator. Y to the 8th over x to the 7th. See if you can do letter D. Some things are going to move, some things are going to stay. A to the 3rd is going to stay because it has a positive exponent, but b to the 4th, that's going down to the bottom because of the negative exponent. C to the negative 6 is going to go up top because it has a negative exponent, so I need to move it. D to the 7th will stay where it is in the denominator. A to the 3rd, C to the 6th, over b to the 4th, d to the 7th. We are going to spend the rest of today looking at putting all of our laws together. And before we do this, there's a little bit of an order of operations we can use with these exponent rules. There are a couple different ways we can do certain problems, but if we follow this particular order, I think it will be the easiest to make sure we get things correct. The first thing we would need to do in any exponent problem is distribute any powers. Distribute any powers, which means using laws 2 and 3. Distribute any powers. The second thing I'm going to do, I do not want to deal with this stuff with negative exponents or zero exponents. I found that when students leave negative exponents and then try to do other operations, they tend to make sign mistakes, and it's going to be easiest if we can get rid of them. So I'm going to make step number 2, get rid of any zero or negative exponents. Get rid of any zero or negative exponents, which means use laws laws 5 and 6. And when we're done with that, we're going to simplify what's left. And I promise I'll make it pause as soon as I write this down. We're going to simplify what's left. Laws 1 and 4. Get those copied down, then I'll show you examples. All right, first problem we're going to do. 3x in parentheses to the negative 2. According to my order of operations, I first need to distribute any powers. Now, when I do a number raised to the negative power, I am just going to leave it as that number to the negative power. So what's 3 to the negative 2? Just 3 to the negative 2. We'll do more in a moment. And then I'm also going to get x to the negative 2. I'm going to get 3 to the negative 2, x to the negative 2. Now, I need to get rid of any zero or negative exponents. I don't have any zero exponents, but I do have negative exponents. Both of these exponents are negative, so I need to move them to the denominator. I'm going to put a 3 squared in the denominator and an x squared in the denominator. And I'm going to get 1 over 3 squared x squared. I'm going to finish this off by simplifying what's left. Well, 3 squared is 9, so I'm going to get 1 over 9 x squared. And that's my answer. 3x to the negative 2, 1 over 9x squared. Letter B, 3, oh, wait a minute. Did I mess up here? And is B the same thing as A? And if so, why is it? And if not, why is it different? B is different than letter A. In letter A, because of those parentheses, that negative 2 applied to both of those things. In letter B, the negative 2 exponent only applies to the x. So, the 3, I don't have anything to distribute, I'm not going to bother with that. But when I get rid of my negative exponents, the 3 does not have a negative exponent. It's going to stay where it was. Then, I'm going to put an x to the negative 2. I'm going to make it x squared in the denominator. 3 over x squared. Please take a close look at A and B and make sure you see the difference between the two. The parentheses makes a difference. In letter C, There is nothing to distribute. But before I start using my division rule that says subtract the exponents, I want to get rid of any negative exponents. So really, all I'm going to do is go piece by piece and decide if I should keep it where it is or move it to the other part of my fraction. The x to the fourth has a positive power, so I'm going to keep it where it was. I'm going to keep it up top. The y to the negative 5 has a negative power, so I'm going to move that to the bottom. I'm going to make it y to the fifth in the denominator. Z to the negative 4, sorry, it's a little bit tricky to see on the screen, but hopefully you have this on the paper in front of you. Z to the negative 4, well, that's a negative exponent. I'm going to write a z to the fourth on the bottom. I kept it, I moved it, I moved it. Now I'm going to go to my denominator. X to the negative 8, well, it's a negative exponent in the bottom. I'm going to move it to the top and make it a positive exponent. X to the 8th. Y to the 12th, well, that was a positive exponent, so I'm just going to keep that where it was on the bottom. Z to the negative 16, negative exponent in the bottom. I'm going to make it positive up top, so z to the 16th on the top. See if you can finish this off. Up top, this will be x to the 12th, because when you multiply those, you add the exponents. In the denominator, y to the 12th times y to the 5th is y to the, add the powers, y to the 17th. As for the z's, when we divide, we subtract the exponents, so 16 minus 4 is z to the 12th on the top. Letter D. You're going to do most of this in a moment, but I do want to get you started. In letter D, should you start by moving the negative 3 to the denominator? Why or why not? We move any variable that has a negative exponent. This is not a negative exponent, it's just a negative number, so I'm going to keep it where it is for right now, and I'll do some work with that later. See how far you can get in letter D. Okay, so I'm going to go, and I'm going to start moving things. I think my a's are both going to stay where they are because they have positive exponents. I think b to the 7th will stay on the top, and c to the 9th will move up top because it was a negative exponent in the denominator. I think the c's will both switch places. C to the 8th will go in the denominator. C to the 10th will go in the numerator. Now, as for this negative 3 over 9, that's just a fraction. Negative 3 over 9 becomes negative 1 over 3, negative 1/3. My a's look like an a to the 4th in the denominator. My b's, let's see, we're going to multiply those. We're going to add the powers. I'm going to get b to the 16th on the top. My c's, c to the 10th over c to the 8th, gives me c squared. I could write it like this. I suppose I could also stick the negative up front and say b to the 16th c squared over 3a to the 4th, some version like that. Letter E. Zoom in so maybe you can see it a little bit clearer. Letter E. I'm going to start by distributing my exponents. What is 3 to the negative 3? I'm just going to write it like that. I'm just going to say 3 to the negative 3. I am never going to evaluate a number raised to a negative power. I'm always going to get rid of the negative power and then evaluate normally. 3 to the negative 3. X to the negative 6 times negative 3 is 18. Y to the 4 times negative 3 is negative 12. Z to the negative 2 times negative 3 is positive 6. We're then going to move things. That 3 to the negative 3 will become a 3 to the 3rd in the denominator. X to the 18th will stay. Y to the 12th will move. Z to the 6th will stay. Finishing this off, I'm going to say x to the 18th, z to the 6th, over 27, y to the 12th. And that's my answer over there. I'd like to see if you can do letter F, which is going to work in a pretty similar way. It's just a multiplication problem, but that doesn't really change things. You'll distribute your exponent, and then basically you just have one long line of numbers raised to powers or variables raised to powers. You'll move things, you'll simplify. See how far you can get in letter F. Okay, 2 to the negative 2, x to the negative 8, y to the second, z to the 8th, times 3 to the negative 1, x to the 5th, y to the 3rd. Oops, it's off the screen. Should look like that. Now I'm going to start moving things. 2 squared to the bottom, x to the 8th to the bottom, y to the second on the top, z to the 8th on the top, 3 to the 1st on the bottom, x to the 5th on the top, y to the 3rd on the top. Okay. Up top, that looks like x to the 5th, y to the 5th, z to the 8th. On the bottom, that's 4 times 3x to the 8th. Well, 4 times 3 is 12 in the bottom. I can deal with the x's, which becomes an x to the 3rd in the denominator. I've got a y to the 5th and a z to the 8th. Y to the 5th, z to the 8th. Oops, off the screen. Over 12, x to the 3rd. I have 2 more to show you. And these really are, actually not 2 more, I take that back, 3 more. I think G and H, though, are about as tough as these things are going to get. See if you can do your distributing step for G and then stop. Okay, so I'm going to get 4 squared. I might as well just do that. I'll say 16. 16, a to the 6th, b to the negative 10, c to the negative 2. On the bottom, because it's a negative number and a negative exponent, I've got 2 issues here. I'm not going to do the problem. I'm just going to say negative 3 in parentheses to the negative 2. Then an a to the 8th, a b to the negative 6, a c to the 4. You now need to move your negative exponents and then see if you can simplify what you get. See if you can keep going in G. Letter G. So I'm going to move things. 16 stays. Negative 3 to the negative 2, I'm going to move that up top and make it negative 3 in parentheses to the positive 2. 8 to the 6th stays. 8 to the 8th stays. Both my b's are going to switch places. B to the 6th on the top, b to the 10th on the bottom. C to the 4th stays in the bottom, c squared gets moved to the bottom. Negative 3 squared is 9, so 16 times 9. A to the 6th, b to the 6th. Over a to the 8th, b to the 10th, c to the 6th. 16 times 9, 144. A to the 6th over a to the 8th gives me a to the 2nd on the bottom because you subtract those exponents. B to the 6th over b to the 10th is b to the 4th on the bottom. And a c to the 6th on the bottom. 144 over a squared, b to the 4th, c to the 6th. I do think that h is as hard as these are going to get. See what you can do. Just go step by step, distribute your exponents, get rid of your negative exponents, simplify what you're left with, see how far you can get, and if you get stuck, push continue and I'll start showing you my work. So I went and I distributed my exponents, giving me this. I'm then going to get rid of all my negative exponents. And I think when I do this, I'll just kind of keep the numbers out front so I don't lose them in the mix of the variables. So 3 to the first, over there. A squared is going to stay. B is going to the bottom. 4 squared is staying up top. I'll just move it out front. A to the 6th up top. B to the 6th is going to go on the bottom. 6 squared is going to go up top. A to the 6th on the bottom. B to the 8th is going to move up top. This will now give you 16 times 36. A to the 8th, B to the 8th. The bottom is 3. A to the 6th, B to the 7th. Let's see, on the top we're going to do 16 times 36. We're going to get 576. A to the 8th, B to the 8th, over 3, A to the 6th, B to the 7th. 576 divided by 3 gives us 192. The A's give us A squared. A to the 8th over A to the 6th is A squared. B to the 8th over B to the 7th gives us B to the 1st. 192, A squared, B. Last one for you to do, and then we'll just summarize all of our exponent rules. See what you can do in letter I. So I guess I could do some simplifying first, but I think I'm just going to go follow the order I've been giving you, and I'm going to distribute my exponents. 3 to the negative 2, A to the negative 12, B to the negative 2, over 4 to the negative 2, C to the negative 10, B to the negative 8. Everything is a negative exponent, so I'm going to get rid of all those exponents and flip everything. C to the 2nd, C to the 10th, B to the 8th, over 3 to the 2nd, below A to the 12th, B to the 2nd. Well, 4 to the 2nd is 16. 3 to the 2nd is 9. I'm going to leave my C to the 10th. I'll leave my A to the 12th. And as for the B's, we'll divide them, we'll subtract the exponents, and get B to the 6th. 16, C to the 10th, B to the 6th, over 9, A to the 12th. Last thing I want to do, I just want to get all of our laws in one place. No, I don't feel like you need to memorize them the way I'm about to write them, but you do need to be able to use them. First one, x to the a times x to the b equals x to the a plus b. And what you need to know is when you multiply variables, you add the exponents. The second one, x to the a raised to the b, power to a power, you multiply them. You get x to the ab. Number 3, x, y to the a. If there's a multiplication problem inside our parentheses, we can distribute the exponents. X to the a, y to the a. Number 4 came in 2 parts. X to the a over x to the b equals x to the, well, I can say a minus b if the numerator is bigger. If the power in the numerator is bigger, rather. And x to the a over x to the b equals, if the power in the denominator is bigger, I'm going to get x to the b minus a in the denominator, 1 over that, if b is greater than a. You subtract, bigger number minus smaller number, you put the answer where the bigger exponent was. Number 5, x to the 0 equals 1, as long as x itself is not 0. And number 6, x to the negative a equals 1 over x to the a. And if I already had a negative exponent in the denominator, 1 over x to the negative a, that's just x to the a. Get these all copied down, please. And we will truly be using these rules all year long. These are not going away anytime soon. You're going to have a little bit of a chance to practice now. You'll try more of those in the homework. And that's about all I have to say with laws of exponents.